I'm Denise Raybould and I will be your facilitator for this Innovation Clinic. Welcome to the Innovation Clinic. How many people have heard of an Innovation Clinic, this thing? Yep. Great to see some hands. How many people have participated in an Innovation Clinic before? Terrific. Now usually we run an Innovation Clinic and we take nearly a whole day for this, and typically we have around 40 people in the room. So this is a little bit different today. But more people means more ideas, right? Okay, so we'll be tapping into all the talent that we have in the room today. So what is an Innovation Clinic? It's an initiative that came out of the Department of Science, Information Technology, Innovation and the Arts, and it uses the principles of open innovation through a facilitated process to drive innovation, collaboration along value chains, to help solve complex and industry challenges and take advantages of emerging technologies. So it really is about collaborating to innovate. Why do we need to collaborate? Our speakers have talked about this already. We cannot solve our problems with the same level of thinking that we used when we created them. We need new insights, new ideas. We need to expand our thinking. And there's more people than just me. There are greater minds than just mine that think this way. So innovation clinics are a tool that can help this collaboration for innovation process. Our world is becoming increasingly more complex, and we're challenged with more complex problems. The waste we generate and its impact on our environment. The detrimental health challenges as a result of our changing lifestyles, diet and environment. And the challenge to find sustainable energy to power our energy-hungry world are some examples of complex problems that we face today with no easy solutions. These types of complex problems benefit from collaboration and from multidisciplinary approaches. We have run a range of innovation clinics on behalf of Decidia to address a wide range of industry problems, everything from biofuels and complementary medicines to sorghum for food and forensic science. So the innovation clinic process is robust and it's available and it's applicable across many industries. Some of the outcomes that we have achieved from these innovation clinics. Earlier today, the Premier mentioned the Agricultural Plastics Innovation Clinic. We held that in June this year in Home Hill. The challenge was to address the use of problem of plastics in agriculture, building up on farm and causing environmental hazards. So within 2 weeks of that innovation clinic, some of the participants to the clinic, Recycling Design and Technologies, had collaborated with the Burdekin Shire Council and Burdekin cane growers to develop and advertise a temporary drop-off location for plastic fluming at the Home Hill Waste Transfer Station. Now that plastic is being incorporated into recycled products. So there's a value chain there. In February this year, we held an innovation clinic looking at how off-grid renewable energy solutions could support businesses in remote areas. One of the issues that became clear in that innovation clinic is that whilst the renewable energy technologies are quite mature, the value chains needed to implement and support the uptake of those technologies are immature or incomplete. So as a result of this, Regional Development Australia has partnered with Gulf Savannah Development to produce a local supplier directory of energy efficient and renewable energy specialists in the far North Queensland region and remote community. And other longer term collaborations are in the early stages. Another example, in 2009, an innovation clinic was held to help the pineapple industry, long an icon for this state, provide additional value to customers and survive the increased threat from imported pineapples. As a result of the Innovation Clinic, a decision was taken to pursue fresh-cut pineapples as a competitive product. As a result of this, Tropical Pines, the company that supplies most of the pineapples to the fresh-cut producers, has increased its production for that market from 2% to 20% over this time. So these are just some examples of outcomes, short and longer term, that have resulted from innovation clinics. Now, each innovation clinic is focused around a key question, okay? The key question for today is how can we maximise waste from food, maximise value from waste in fruit and vegetable supply chains? These key questions are developed from consultation with the stakeholders and from market research, where we scope the opportunity or problem, the size and the boundaries of that. We have a look at the current approaches to addressing the issue or the opportunity, and we identify the thought leaders in that field and related fields who are pushing the boundaries and may be able to open up new opportunities. The process, so today we're actually learning about an innovation clinic and we're modelling it. We're all going to participate in this. And today's process is going to be Ross Naidoo from Dept will be our first speaker. We're going to open up by looking at the opportunities. So Ross will present the opportunities in terms of the economics of food waste and the opportunities for use. Fiona Waterhouse from Utilitas will present the economics of the opportunity to generate organic energy from food waste. So if there are so many opportunities, why aren't we already making most of this? Our industry panel will help us understand the challenges and barriers that there are to uptaking waste from food and incorporating it into new products. So on our panel, we'll be joined by Amir Shoshani from Rugby Farm, Nick White from Gourmet Garden, and Angelo Andronis from Integria Healthcare. And they'll provide their insights about what they look for in opportunities. So then, with so much talent in this room, we are going to throw it open to you through a process and ask you to contribute your thoughts as to how we can create more value from food waste for economic benefit, and we'll capture those thoughts in our group work and action planning. Now, typically, in an innovation clinic, we would do the scoping and the market research and send out a briefing paper to all participants prior to the clinic so that everyone has the same basic level of information when they join in. Now, we haven't done that today, of course, so I'll just take a minute to set the scene. For Queensland produces in excess of $2.4 billion from its fruit, vegetable and nut production. There are opportunities to create additional value to fruit and vegetables waste through some possibilities looking at high-value products such as nutraceuticals and functional foods, through the fresh cut industry and incorporating it into food products, and through energy generation from waste through anaerobic digestion and pyrolysis. I would now like to invite Ross Naidoo to present and to provide more insights following on from this. Ross is the Food Science Liaison Officer with Innovative Food Solutions and Technologies, a unit of Queensland's Department of Agriculture, Fisheries and Forestry. He has formal qualifications covering science and technology, export management and business. Ross has over 26 years' experience in food manufacturing, research and development, and industry and business development. In his current role, Ross focuses on assisting Queensland agri-food industries better utilise food research, development and extension capabilities to accelerate innovation within businesses and industry as a whole, ultimately improving productivity and competitiveness and working towards that goal of doubling agri-food production by 2040 in Queensland. Would you please welcome Ross Naidoo?
Thank you very much, Denise, for that wonderful introduction. Oh, good. So I don't have to do terribly much. Do you have to press anything? Okay. Just a little bit of information. This is going to be a very quick coverage of the background and the possibilities that one could enter into creating future value from horticulture that's actually being grown at the moment. Excuse me, right. A bit of background stuff which you need to know about. It's estimated that 277,000 tonnes of horticulture is lost each year in Australia, approximately 25% of production. Equates to around $155 million a year. The majority of this waste is due to failure of the crop to meet strict retail quality standards, and that can be up to 50% of certain crops. Generally, what happens is the product is either dumped, used for stock feed, or rotary hoed back into the soil. There's also a huge amount of resources that actually goes into producing that in terms of fertilizer, fuel, etc. FAO have set a target of about 19%, so to drop that figure from 25 to 19%. A little bit of economics for the farmers of you that might be present, and there might be the odd one of you here. It's been estimated by our department that if you're, say, a fresh qualifier grower, if you plough product back into the field, you're probably losing between $7,438 per hectare. That's just from fresh cauliflower. Fresh cabbage, around $3,964. So there's a bit of a range depending on what your crop is. If you look at further processing, add another $7,603 to it. So we're losing a lot of economic value by simply ploughing back into the fields. It might make sense from a nutritional perspective, but economically not necessarily so. General waste, Sydney markets, general waste, 80 tonnes a day. So we're focusing on this area because this is where the concentration of horticultural waste generally goes if you've got a centrally planned economy. 20,000 tonnes per annum in Sydney. Melbourne, 6,000 tonnes per annum of green waste, 24 tonnes a day. Brisbane markets, 29 cubic metres per day. Sorry, I didn't have that in tonnes, but you could pretty much have a density of roughly 1, so that's probably around 29 tonnes a day. So 72,000 tonnes a year. Adelaide doesn't have a collection centre, so we don't have figures for Adelaide. Perth, 4,000 tonnes a year, 20 tonnes a day. So you can see there's a considerable amount of green waste that we've got that's centralised, which we should be able to do something with. Okay. Just looking at this pyramid, and it's not rocket science, it's fairly basic. It's almost Maslowian. Right at the top is your fresh cuts, your value-added, your processed stuff, which you buy in your supermarkets every day. Then as we start to move down the chain, you can see there's nutraceuticals, which we can extract. And there's some of those described below. I won't bother going to the names of them, because at the end of the day, we want to know if they've got commercial value, not whether they've got really big scientific names. Okay. Dietary food fibre from bulk foods, which you're well aware of, stock feed, as you're well aware of, and also bioenergy. So in essence, that pyramid is going to give you a bit of a diagram or model of what we can do with our product. What we haven't been looking at very closely in Australia is probably the nutraceutical area, which is an area which you can extract extremely good high-quality products from waste. So if you're selling something for 90 tonnes, $90 a tonne for cattle feed, you might be able to extract hundreds, if not thousands of dollars per kilo from that product before you can actually resell it as cattle feed. So what we're trying to do is elevate the primary industry into a tertiary phase. So at the moment we tend to think of agriculture as a primary industry, food as a secondary industry, while nutraceuticals can be considered the tertiary industry. And the sort of research that we do down at Cooper's Plains is very much about applied research in being able to extract that stuff so that companies can actually use it and sell it, not necessarily write papers about it, with all due respect to researchers. Okay? So, what are the possible uses of vegetable waste? Extracting bioactives, nutritional supplements, nutraceuticals, natural food colouring. I'm going to concentrate on anti-obesity because I'm overweight. Okay, extraction of volatile components, flavours, perfumes, cosmetics, dietary fibres that fortify foods. Using as a growth substrate for larvae. We know that our fishing stocks and natural stocks are declining. We have to rely on aquaculture. We have to get high protein stocks into that. Can we use some of that waste material to grow larvae, etc., to provide protein stocks for aquaculture, being more sustainable? And then we can start to look at high energy production, such as methane production of biochar. Right? Composting. what we've been looking at very solidly is the stuff at the base level, not the stuff above it. We're not thinking strategically about optimizing that resource that we've got. We've got to look very strategically about taking something that's a kilo of this and what can we take out of there as much as possible to make $1 from, right? So bottled water. Before my generation, we opened a tap. If you had a tap and you drank it, who would have thought that a litre of water was going to be worth more than a litre of fuel? Okay? It's what we're saying is let's take that resource and try and extract as much out of it. Without going into the science terribly much, polyphenols, basically there's certain components in agriculture, plant materials, which disrupt fat cell development. When I say that it disrupts it before the fat cell is developed. And these exist naturally within plant materials. And they're an example of them. There's 3, phenolic acids, flavanols, flavons, okay? They're just 3 examples. And the reason I've got them up there is I'll hopefully show to you that they're actually in the commercial world at this point in time being sold, right? High levels of these anti-obesity components are in sweet potato, even higher in the sweet potato leaves, in onions, in broccoli, in artichokes, and celery, and red grapes. So all of that waste material that gets dumped because it doesn't make the retail shops, we can start to pull that stuff out of there and sell it as an ingredient, which you can then add to your coffee, your tea, your wine, your beverage, so that you can actually hopefully start to leverage the anti-obesity message. Okay. Orange fresh sweet potatoes are the most potent, red onions, red capsicum, red leafy lettuce, red kale. Kale's a traditional food that's eaten in Africa. If you go to the Maruka supermarket, there's a lot of it there because there's a large African population. They can't get enough of it. I think there's a couple of growers in the Granite Belt area, but they're all sort of small growers. Okay, this is why I need my glasses. Here are examples of some products in the world. This is off the Innova database, which has about 2 million food products. This is an example, and hopefully you can see it. It's got flavanols in there. I don't know if you remember the previous slide. I said flavanols. So this is 60 tablets sold in the US for $45, right? And that's a product from Douglas. So what they're doing is they're starting to leverage that sort of information. They're extracting it out, stabilizing it in powdered form, putting it in capsules, and then selling it, right? It's not a great deal of rocket science, to be honest. It's actually fairly simple stuff. And it's a technology that we play with down at Cooper's Plains with David Paulson as our science leader. There are companies in Queensland who are really interested in doing this, and I think Chris Devaney, who's here from Fabco, is one of them. And he's one of the people who's quite forward-thinking from an agricultural background. Here's another product. And it's got, once more again, it's got, supposed to be highlighted there, but it's got quercetin in it. I don't know if you saw in the previous slide, quercetin was one of them. They're selling quercetin as one of the imports, and they're selling that product, the 12 ounces for $55 US, right? So that's one of the ingredients just present. Right? Antioxidants, the other important component. You've got 30 pills there being sold for $17 US. This is the stuff we can pull out of that waste material that Woolworths and Coles will not take because it doesn't make the QA standard. And the poor farmers are growing it and then have to plough it back into the ground because they're losing that $7,000 to $14,000 per hectare because no one can do anything with it except give it as cattle feed, or someone has to take away and dump it. And that's a cost to them, right? This is about using, I think you'd call me a positive deviant, because what I'm trying to do is actually say waste is not waste, it's good. Luteins, which are good for eyesight, that's another one, and it's a flavanol. And that's come up as well. And as you can see, these are coming up in separate products, right? And I'm going somewhere with this, by the way, right? This is a weight loss product, incidentally made in Zambia, and I spent some time growing up there, which is interesting. And I think the reason it's made there is because the regulations permit them to make it, but they sell it globally. And when you look at it, all the language that they've incorporated is about anti-obesity activity. Okay. FUM. This is blood pressure formulations, and the extract is from wine, pressed wine. So all the grapes, that obviously those of us who are wine drinkers like myself, but all the grape crush, that's a product that's from that. Okay, so that's something that can be done with the grape crush for the industry. Quercetin, okay, if you just go and see, well, what's the worth? You can get it from China for $100 for 300 kilos. Quality, very dubious because we don't know what the heavy metal content is, etc. Australia's got a very good reputation for its raw ingredient supply, and don't forget that. Don't ever undercut that. And we can sell the benefit of that through our value-added chain. If there's one observation I'll make about Australia is that our tall poppy syndrome tends to mean that we pull our stuff down to the normative. And we've got some of the best production in the world, and we don't hold it high enough. That's my opinion. And I think if we did that with our agricultural stocks, we would actually do very well. General markets, well-being, cosmetics, animal health, okay? And the key reason I put that up there was that all of those ones that I showed you as individuals, if you put them together into one product, that would optimize your anti-obesity product, right? At the moment, they all exist in separate products. If you mix them together, you would optimize your anti-obesity formulation, right? So people already do them individually, but they're not doing them together. Thank you very much. That's my presentation for today.
Thank you, Ross. Some interesting facts and ideas to consider. I'd now like to introduce Fiona Waterhouse. Fiona seed-funded and is currently the CEO of Utilitas, a specialist biogas asset development company. Utilitas currently has 1.8 megawatts of client projects in construction and is raising capital to build a portfolio of biogas projects. Fiona was on the board of EcoFund Queensland and a member of the Australian Government's Clean Technology Innovation Committee, where she worked with Financial and Energy Exchange to establish the environmental product developer NVEX and SimVSE, an innovation-themed equity market board. Fiona has qualifications in manufacturing management, environmental studies and business. She is an industry fellow at the Australian Centre for Sustainable Business and Development at USQ. Please welcome Fiona Waterhouse.
Thank you. Hi, everyone. I've got 10 minutes to get you excited about organic energy. So it's kind of a big task, and I can talk under wet concrete, so 10 minutes is kind of not very long. Let me just work out how to drive this thing. Okay, so I'm going to talk about the organic energy industry, which I'm pleased to tell you, and you're going to hear it here first today. Queensland actually has a bit of an edge in it. Not only have we... So 3 of the sort of 6 main companies that are making a play in the organic energy space are actually Queensland companies. So I think in the next few years you'll see that energy from biogas, which is the... oh, what happened? Sorry. Don't give me technology. Energy from biogas, which is the natural breakdown of organic materials. It's mostly methane, and if you put your hand on your stomach, you're basically touching a biogas plant. The scientists in the room will be cringing at me, but so essentially you take organic materials, so a mix of proteins, fats and carbohydrates, you macerate them up in your macerator. It goes down in your in-feed system where it's heated to about 37 degrees. It's agitated. There's a certain residence time for different materials depending on what you've just eaten. You get a gaseous phase, you get a liquid phase, and you get a solid phase. Welcome to biogas. That's what a biogas plant does. Yes. So just to give it some perspective about the organic energy opportunity, every year Brisbane throws away enough organic waste to fill Suncorp Stadium up to the crossbar when we're playing football. It's a pretty scary concept. That's about enough energy to power 20,000 homes. So if you have 100 tonne of food waste, of medium grease content, in a day you will be able to produce a megawatt every hour of power. So a megawatt of installed capacity from about 10 truckloads of organic waste. I did it again, sorry. So when you look at the various, and we know this intuitively, so today you're actually going to go through a bit of a learning curve, and I hope you come out the end being experts in biogas because you realise you have a biogas plant, but you also know how one works because fats and grease, for example, give a lot of energy, but you also know that if you ate butter for a week, and only butter for a week, you would be a very sick puppy, and so would a biogas plant. So you actually have to have a proper mix of carbohydrates, fats and proteins in us and in a biogas plant. Interestingly, something that will be new to you today, I'm assuming, is cow manure is the Yakult of biogas plants. So we like in our biogas plants to have a supply of cow manure because it kind of acts like those little Yakult shots that you get at the shop to keep your tummy nice and healthy, and cow manure does the same thing. But you can see from this it actually has quite low energy potential in comparison to, say, bakery waste or food scraps. So that's, I guess, taking a look at waste from an energy perspective, which is the way we look at it and hopefully the way you will now view it. I have to report that we are nowhere near the podium internationally when it comes to this. Germany's on the top of the podium. They have 3,000 megawatts of installed capacity, 8,700 projects, enough to power 4 million homes. This is mainstream stuff in Germany. If you asked a 6th class person in Germany what a biogas plant was, they would be able to tell you. They would tell you that the heat from one heats their swimming pool, and possibly the powers also provides heat to reticulated heat in their village. So they would definitely know what it was. They would know that the fertiliser from them is what gets spread out on the fields, and they would know that all the animal manures, the sewage and crop residuals and food waste in the area gets put into their biogas plant. In Australia we have 29 projects. We're building 2 at the moment, and I'm raising a portfolio to build another 20. But basically we're a long way behind the 8 ball. New Zealand is ahead of us, just for those of you who are competitive sport-wise, and that really sucks when New Zealand's ahead of us, so we really have to kind of lift our game. But as I've said, Queensland companies are actually leading the way in this industry, and I think, you will see the results of that in the future. So why now is it becoming something of interest to people? Recovering energy from waste in Australia has not been very exciting for people because the price of gas and the price of electricity has been just too cheap for anyone to bother with it. It's a hard game to get it started. It is a mix. It does require a tremendous amount of collaboration and a tremendous amount of capability. We have scientists, engineers, we have our own laboratory. In fact, we built our own lab privately and we took it back to a university, which is kind of cool. So our lab, our biomethane potential testing lab, now sits in our block at Gardens Point at the Queensland University of Technology. But we built it privately first, and because there was really no market or understanding for the kind of thing that we needed to be able to use the science to spec our engineering and to design our plant. So now we've taken knowledge back to the university, and we're partnering with QUT basically to look at how they can help gear up so that we can build 20 plants and manage the science for that, and that Queensland can lead an industry. So when you're creating an industry from scratch, you need a lot of different people in the game with you. But the reason it's starting to become an issue and people are taking it more seriously now, if you've got an organic waste stream, it means now that you can recover gas, you can put that in a burner to displace natural gas or coal, you can use it in a generator to create electricity, and in creating electricity we use combined heat and power units, which means you also recover the heat from the electricity generation process, so you can use that heat back in the production process. So it's a very efficient use of a waste stream to displace retail grid power or fuels that might be used in the production system currently. It does compete internationally. Biogas is a subset of biomass, and this is statistics from the United States, from the Department of Energy, and in the United States biogas plants can produce electricity at between $97 a megawatt hour and $136 a megawatt hour. That's our goal for our project portfolio, is to get to that point where we're producing energy at less than $130 Australian per megawatt hour. To put that in perspective, our industry clients would be paying anywhere between $175 and some of them are paying up to $300. If they have diesel generation, then they're paying up to $600 a megawatt hour for their energy. So to give you an example of the opportunity for, say, a fruit and veg processor, if you had 40 tonnes a day of vegetable waste, you would be able to use that to displace some of your electricity. Depending on how big your operation is, it may be all of your electricity. It could also be used in various ways to displace the cost of refrigeration. This is what a plant would look like. So a half a megawatt, 500 kilowatt installed capacity biogas plant is what you would get off 40 tonnes of fruit and veg waste a day. And basically, just like our stomach, you have an in-feed system, you have a macerator, you have a bit of a storage tank, so you then have a digester that agitates and keeps it warm at 39 degrees in this case. You then take the gas off and put it through, in this case it's showing a combined heat and power unit and supplying electricity, but also supplying heat back to the plant and also to the farm. It then is also providing a digestate which can then go and be used in either liquid form or solid form or a combination of both to displace chemical fertiliser. So these are the economics. The biggest challenge at this point, and Denise alluded to this, even though this is well-proven technology and we use world-class technology from some of the biggest suppliers in the world. So when you talk about collaboration, we're only a small Queensland company that hopefully is going to grow really fast, but we have the biggest supplier of tanks in the world, and they take us very seriously, which is really interesting. They see us as a growth potential stream for them in Asia. So, to be a small Brisbane-based company and have the world's biggest supplier of tanks as one of your suppliers is quite, it's quite a cool and very good situation. So the economics, basically the hardest point with them, this is essentially process engineering. The tricky bit is integrating these plants with existing production systems to optimise how they integrate and to reduce the costs. We don't have a very mature supply chain in Australia, so everything we're doing from scratch. When it comes to compliance, and Wagner's talked about this, we have to basically help the regulators to write the standards to be able to compliance these kinds of projects. A 200 kilowatt project will get treated under the Petroleum and Gas Act in Queensland the same way as a 2,000 megawatt project would, and we have the same compliance burden. So those kinds of things are definitely barriers to development of the industry, and it is being addressed and taken seriously, but when you're pioneering an industry, they're the things that you run up against left, right and centre. So, does organic energy make sense? Excellent, thank you.
I'd like to invite our industry panel to the stage, and as they are making their way up, I'll just run through some introductions for them. So we have Amir Shoshani, who's making his way up here. Amir is the operations manager at Rugby Farm. Rugby Farm is a large Australian operation which grows and packs vegetables for all national central markets and numerous export markets. Rugby Farm works closely with other growers throughout Queensland to supply produce 12 months throughout the year. Amir,
Yep.
from your perspective as a major vegetable producer, what are the challenges that you face in creating value from your food waste? And can you give us an idea of how much offcuts and what is technically waste that Rugby Farm would produce?
From the product that come actually to the packing shed, we produce more waste than Sydney and, according to Ross, Sydney and Brisbane markets combined.
Wow.
That's 100 tonne a day in the busy season, which is 6 months, and probably around 20 to 30 days on the off season.
So 100 tonne a day of offcuts and...
But that's a product that arrived in the shed. We got quite a lot. All the product we're picking in the field, lettuce, cauliflower, cabbages, they're just left behind in the field. So if we can utilize it, we can bring it as well with the waste, and we have probably another 40 tonne a day, I would say, easily.
Wow. So Amir, what are the challenges that you face, just quickly, in terms of creating value from this waste?
Like, as you saw from Fiona, from the analysis of the process grower, that's, I think, very similar to what we did together. So the problem is a mixture. The problem is combining other waste to our waste, because our waste is a little bit wet. It's take a lot of energy to dry it. If you do it one way, it's not producing enough energy. It costs a lot of money to install a system, and it's a huge, like on the picture on the screen, it looks like a nice little area, but it's actually take quite a lot of land, so you need to put it in the right place because we're still expanding. So we'll get there eventually. But
okay. So whilst Amir and Rugby Farm have the volume necessary for to generate energy on farm, there are still challenges in terms of that implementation and the cost. Yeah. Okay. Thank you, Amir. Our second industry panellist is Nicholas Wright. Nicholas is the CEO of Gourmet Garden, a food manufacturer that specialises in herb products. And you'll hear more about Nick and his business in the presentation following this session. So, Nicholas, from your perspective as a food manufacturer, what are the things that you look for and the challenges you face in uptaking a food byproduct and incorporating it into a new product?
Well, I think if in our business as a herb and spice grower, like we don't generate a lot of waste, so whatever we don't utilise for the paste products, we put back in the soil for the organic benefits of doing that. I was thinking more about this question from the context of that example we just saw then up on screen. If the biggest driver of this waste is retailers wanting very tight specifications, and clearly that to me says that there's a potential consumer benefit opportunity to deliver that. And you look at those numbers of 1.2 tonne per store per week. That's an enormous benefit. Not in my current sort of industry, but I used to work for Kraft Foods, and I think one of our most loved brands was a benefit straight out of a food waste product. So, Vegemite was a product that was generated purely from the nutritional benefits that were coming out of brewery yeast. So I think if you go down that path, and I think Ross talked about it, that if there's a genuine consumer benefit that can be delivered, then I think there's an opportunity to develop products specifically to do that. In another project I was involved with in Kraft, most of you would remember a brand called Tang, like powdered.
Yeah.
Well, in South America, that's still a very prevalent brand. And when I was working with Kraft, it was a constant project to say, well, how could we utilise some of the nutritional benefits from juicing, like all the fibre and nutrients that were left over, could we put that into a powdered beverage? But that was 10 years ago, and that was never achieved. But that would have been a great example of how a mainstream product could have benefited from a substance that had nutritional qualities that was generally a waste product.
Okay, great example. Thank you, Nick. Our third industry panellist is Angelo Andronis, the General Manager Technical at Integria Healthcare. Integria is underpinned by some 60 years of science and research into herbal remedies. Integria owns some of the most reputable and innovative natural healthcare brands, both for practitioner-only and retail brands. So, Angelo, from your perspective as a nutraceutical manufacturer, what do you look for in an opportunity to uptake a new ingredient for a product, and what are the barriers and challenges that you face?
What we look for is basically something that's got a commercial application, i.e. it's got to have some sort of therapeutic benefit to a consumer, and that makes it commercially viable. The biggest problem we face is the regulatory hurdles in our industry. We're governed by the Therapeutic Goods Administration, which means we just can't go and use any products. It actually has to be on a list that the government put out that deem it to be safe and usable. If it's not on that list, then you have to go through a different set of hurdles to actually get it on there, and that can be quite expensive, anywhere between $10,000 to $60,000, if not more.
Okay. Thank you, Angelo, and thank you to our panel members for your insights into taking up these opportunities. So, let's throw it open now to the group. Question I'd like to put to you is, how can we unlock the economic potential of food and vegetable waste? So in a typical innovation clinic, we would have a whole group discussion, and but since we have so many people in the room in a short amount of time, we're going to use a different process today. So everyone should have a notepad in front of you on the table, okay? What I'd like you to do is, reflecting on the discussions we've had and the inputs that we've had, please, without talking to your neighbour, write down some of the things that you think are definite opportunities to unlock the economic potential of food and vegetable waste. Now, some of the prompts for that might be, what are the big opportunities to create value? How can we rephrase issues and impediments as opportunities, and who needs to be involved? So let's take, say, 3 minutes for you to work individually and just jot down some of these ideas. I know that we won't be able to capture all the ideas today, but at the end of this session I'll be asking you to tear off your sheet of paper and put it in the middle so we don't lose your good ideas. In an innovation clinic, we would get to the next action or the next couple of actions. So then a lot of information has been discussed, a lot of ideas will be collated. What is the first action that should be taken coming out of this? I'm going to close the Innovation Clinic at this point. Thank you very much for your active participation today. It's been a great audience. You've discussed things. There's been good levels of interaction. I hope that you have a better understanding of what an Innovation Clinic is and how it can address some of the complex problems. If you have an industry challenge that you think may benefit from a collaborative and multidisciplinary approach, bringing together research organisations, government and industry to look at the problem through a new lens, then please contact either myself or Alan Murgatroyd from Decidia, whose hand is raised over here. Okay. Thank you very much for your participation.